Part 2 of Fundamental Theorem of Algebra video. Okay? Working backwards. Given solutions to an equation, can we in fact find the equation? Let us state that we are given the x equals 2 and x equals -3 are solutions to a quadratic equation. What in fact is the equation? Well, we reason backwards, okay? If x equals 2 is a solution, then x minus 2 is a factor. If x equals -3 is a solution, then x minus -3 or x plus 3 is a factor, implying that the product of x minus 2 and x plus 3 would be our equation, which in fact is x squared plus x minus 6. Of course, going backwards, that's what we would find, that they were the solutions. So you get the idea. So if you have the solutions, x minus that value is a factor. And the product of all those factors would give you the polynomial in question, in this case, the quadratic. Okay, let's work with another one. If x equals 3i is a solution, and x equals 2 is a solution, determine the equation. Well, first off, we reason as follows, okay? That if x equals 3i is a solution, that's an imaginary solution, and imaginary solutions always come in pairs. Always come in pairs. Which implies that, okay, if we have x equals 3i as a solution, then x equals -3i is likewise a solution. And additionally, if x equals 2, then x minus 2 is a factor, or x, and such that the product of these three, x minus 3i, x plus 3i, and x minus 2 must be the polynomial, must result in giving us the polynomial in question. Okay, so backwards again, looking at that. Since x equals 3i is said to be a solution, it is imaginary, it can only come in pairs. 3i and -3i are solutions, implying that x minus 3i, x plus 3i are factors, along with the x minus 2 as a factor coming from x equaling 2 as a solution. The conjugates always multiply nicely. Notice they're like a sum and difference of binomials, okay? So they should come back automatically to x squared minus 9i squared, I squared being -1. This becomes x squared plus 9. Along with this product gives us, okay, a cubic polynomial, x cubed minus 2x squared minus 9x plus 18 equaling 0. That is the equations whose solutions are 2, 3i, and -3i. You should check that. You should be able to factor that backwards and see that you get that. Okay? Moving on. Okay, we now look at this guy. Write the equation of the polynomial whose roots are x equals -1, having a multiplicity of 2, meaning it appears as a factor twice, okay, along with 3 and -2. So x equals -1 as a solution would have a factor of x plus 1. Since it's a multiplicity, okay, it would be x plus 1 times itself, giving us x squared plus 2x plus 1. Along with the solutions of 3 and -2 and the associated factors of x minus 3 and x plus 2, whose product is x squared minus x minus 6. This trinomial times the trinomial, which you could ask your calculator to do, I would have no opposition to that, okay, would give this polynomial simplified down to an x to the fourth, what we call a fourth power polynomial. Okay? Now, we wouldn't know at this point how to factor that, but, okay, working with the solutions, we were able to come up with the polynomial. Okay? All right, and like I said, you can confirm with your calculator using the F2 expand feature to verify that. Another one. Okay, we're back, and we have a few of your classmates who want to say hello, so here they go.
Follow my Insta at abass.
Yo, it's R Seneca. It's Miller time, baby.
Okay. Enjoy that moment, okay? So, let's look at another problem here, okay? We're telling you what the solutions are, okay, and asking you to find the polynomial, all right? So, solutions are 2 and negative 2, implying factors are x plus 2, x minus 2, all right? Also, solution is 2/3, so that's x. If you cross multiply here, you can deal with this a little easier, okay? As 3x equals 2 or 3x minus 2. And likewise over here, since x equals negative 1/2, cross multiplying gives you this, all right? And now you have these 4 factors which need to multiply out. As you can see here, these multiplied out as sum and difference binomials. Okay, these multiply out using FOIL method. And again, then the longhand would be x squared times this trinomial minus 4 times that trinomial. You should be able to follow that. You should also be able to do that manually, but no problem if you want to ask your calculator, okay? And verify that if you would with your calculator. Okay. Let's take a look at another example. Find the equation whose roots are, okay, x equals 1, having a multiplicity of 2, meaning x minus 1, x minus 1 is a factor. 0 is the solution, meaning you're going to have a factor of x in there. 2 minus, okay, root 3, okay, 2 minus root 3, and 2 plus root 3, okay, 2 minus root 3 and 2 plus root 3, implying that, okay, you have 2 minus the quantity 2 minus root 3 and 2x minus 2 plus root 3, okay? Obviously, looks like we did this multiplication outright first, all right? Revealing this kind of a long-winded quadratic, which comes right down to this. So, okay, these products here, revealing this, all right? Okay? Their product is the 4th degree times that x is the 5th degree, okay? And then, as we said here, one solution of the form 2 minus root 3, okay? Not that this is a, not that it's an imaginary solution necessarily, I should cross that, okay? But it is a non-real, I'm sorry, an irrational solution, which is going to have a pair with it, as you can see there, okay? And I'm going to fix that so it does not say imaginary, but does say, okay, has a irrational, okay? Find the equation of the polynomial with roots. -1, 2/3, okay? -4 plus 5 root 2, and negative 4 minus 5 root 2. Okay? There's your roots. There's your factors. Okay? The product is very long-winded. Okay? And again, I state no problem using your calculator to find those. Okay? And also state that it's not impossible, simply tedious. But you can do it. So there you have it, okay? There is your second video on the fundamental theorem of algebra.